Welcome to this week's narrated PowerPoint presentation. This is number 7 in the series of COVID projects that I've been presenting weekly. This project continues my love for creating miniatures of existing clocks. And Verge and crown wheel escapement lantern clocks from the 1700s are a particular favourite of mine, so I decided to make a miniature. Without making the wheels, where could I source tiny Verge and crown wheel train for my clock? From a Verge watch, of course. So I'm going to show you how I rebirthed an early Verge pocket watch. To make a clock from a watch movement, I had to think laterally about the length of the arbors, because a clock typically requires longer arbors than a watch. But if you go back to the very beginnings of pocket watches, where the pocket watches were very, very thick and were called oignons or onion because of their shape, the arbors in those watches are very much longer than later model pocket watches. So here I go back in time to 1699 in London, in a street called Little Britain. Fortuitously, I was able to obtain a part movement from a maker known as Sam Stokes, who worked in Little Britain in 1699. Now, this movement is typically beautifully engraved and would have been a magnificent watch, but it had been cannibalized, and the only things remaining were the wheels between the plates. Perfect for my project without destroying a beautiful watch. Here you can see what I'm talking about. This is a very early pocket watch, an oignon cased watch, very, very thick, and as you can imagine, the arbors in this watch are quite long. My project was to construct a Verge escapement lantern clock in the style of one of the clocks in my collection, an Italian lantern clock from 1700. Here is my magnificent Italian lantern clock, made in Bologna in 1720. It is 260 millimeters high from the bottom of the feet to the tip of the finial at the bell. That's 10¼ inches high. So I was planning to make a very small replica of this model. In designing this miniature clock, the pendulum really is the first thing I look at to determine how high the clock will be, because I want the pendulum to swing around about the bottom plate of the movement and no longer. This watch movement that I had chosen had a beat rate of 14,400, which I determined from a wheel count. Now, 14,400 beats per hour amazingly is equivalent to a pendulum length of 62.13 millimeters. So using that one length of a pendulum, I was able to design the entire frame and the layout of the wheels for this miniature clock. Using my newly found pendulum length of 62 millimeters and scaling that from the pendulum length of the large model, I was able then to scale the movement plates and the pillars all down to fit the pendulum length. And in this picture you can see I've already made all those components, including the 2 vertical plates inside with the wheels mounted. Note also that the original fusee has been converted to a rope drive wheel. There was enough metal in the fusee to do that. Here you can see the entire watch wheel work, going from the drive at the bottom through up to the escapement at the top and the motion work on the front. You can also see that this thing is so small, it's less than a D-size battery. All the watch wheels were able to fit between the plates that I'd designed, and all fitted perfectly. But to have the pendulum down behind the clock, I had to extend the original pallet arbor way out beyond its original so that it could be pivoted in a cock at the back and carry the pendulum swinging down behind the plates. Having proved that the mechanism was going to operate correctly, and in the left side you can see the weight-driven movement now with the pendulum attached and running. It was time now to get on with the decorative parts, and you can see that I've turned some of the original blank pillars to their final shape, created some feet, and getting well on with replicating the original Italian lantern clock model. Progressing slowly through the replication of case parts, here are the finials and a bell post. All the frame and decorative components are complete, and now I'm laying out two brass plates, one for the front carrying the dial, and for the center of the dial a small alarm disc. Typically, small lantern clocks were travelling alarm clocks, and hence I've made an alarm work to fit into this miniature clock. It required a Verge crown wheel, an arbor with a hammer attached to the top, and then a let-off detent when the correct time was reached. Here you can see the beautifully engraved dial plate, chapter ring, and the alarm disc at the centre, all replicated from the full-size clock. Also, a fret above the dial between the top finials was replicated from a pattern in the spandrels. Project complete. Target achieved. A miniature replica as small as I could possibly make it for the 62mm pendulum. Compare the dial work and you'll see that the miniature has a single hand and no minute marks. Apart from that, the replication of the design and the style are very, very close. Side by side, the model clock standing 260mm tall, or 10.5 inches, compared to the minuscule clock made from the watch at 90mm tall, or 3.5 inches. Substantial reduction in size. That completes this project. Thanks for watching. If you have any questions or comments you'd like to make, you can send them to me at the email address shown at the bottom of this page. Thank you and keep safe.